It's Roger once again, Mudfiles University, continuing on with the series about energy and how things interact and acoustic levitation, Argonne National Laboratories. Now, they're talking about standing waves, I'll explain what they are, and resonance frequencies, again, I'll explain what they are, and how they can actually levitate water droplets in the frequency nodes, they call them. Okay, so let's watch what this guy does, and then I'll explain to you what I think is going on. All right, so here he goes. Now, this is Argonne National Laboratories, and they have, well, here, before we do it, let me just explain to you what is going on. I saw something up here. Oh, here we go. Now, the acoustic levitator uses two small speakers, boop, boop, one on each of the top, to generate sound waves at frequencies slightly above the audible range. So it's, you know, very, very low frequencies, roughly 22 kilohertz. When you think kilohertz, oh, that's a lot. No, it isn't. They're very, very slow waves. All right, now, when the top and the bottom speakers are precisely aligned so that that wave and this wave hit head-on, they create two sets of sound waves perfectly interfere with each other. So they smash into each other, and it's setting up a phenomenon known as a standing wave. Now, I will explain to you what I think is a standing wave. Now, then they say at certain points along the standing wave, there's nodes. And there is no net transfer of energy at all at that node, is what they say. Because the acoustic pressure from the sound waves coming up is sufficient to cancel the effect of gravity coming down. Really is basically what they're saying. Light objects are able to levitate when placed at the nodes. Now, watch this. Very, very cool. And I think I understand it. Here we go. Look at that. No, he's got, well, anyway. You see his little spoon is brass, so it's not affected by the, anyway. Oh. Now, you see he's drifting them up and down by changing that wave. That's called attenuation. When you pull them apart and so forth, what he's doing here, now he's trying to overlap them and create that resonance. Because one's going one way, well, one's going up and one's coming down. Anyway, that they didn't show it all that well, but I will show it in a different place. But what he is showing as what they talk about as waves coming each other, they're not waves. They're, if you looked at light, this is what light is. Light comes at you spinning like this in a right-hand rule. If you looked at it from the side, yeah, it looks like a wave. Those are high frequency waves. They're really spinning fast. Those are slow waves. The red waves are spinning slow. But literally, and I can show you, I'm going to show you this. Light is that particle which is at the tip of this wire, and all there is that. But when it spins, because it's negative, everything around it gets pushed away because everything else is negative. It creates these huge magnetic particle fields around it. We can only see them when we have accelerated them. I don't see them any other times. Well, I have seen them a few times, but I can't explain why. Actually in open air. And people are seeing them now, whether we're getting high energy particles coming in, I don't know. But I will show you what they are. Okay, just a few basic things to remember. I'm sure you know this if you've been with me at all. Now, this is light from a red laser. Right. We take that wave and then we accelerate it through a venturi over here. You see the wave being sucked through the venturi. It's elongating and accelerating, and the particle beam is there. Plasma is created here. The interference patterns are here, and the reverse electromagnetic field is there, which is because of this concussion of the particles. These are now displayed as the particle that they are. The particle is here. Again, it owns a region around itself, so it shows a huge concussion as it flows through the air. Once they stack up on themselves, because again, they own a region, when they concuss, they glow. And they send out this reverse field, making these little particles glow, which are the ether in the air, which is everywhere. It's not only in the air, it's in space between the sun and here, which is, it is dark matter and dark energy on its way to becoming light and electrons and heat and energy and the things that we get burnt by the sun. It is the particles that are spinning through space. Now, when they enter our atmosphere, they end up collecting on things and growing plants and being absorbed by the earth and creating heat and shaking everything and light and so forth. So that is the nature of the particle of light. What happens after you plasmatize it and force it to become so excited that it propels itself away from itself so fast that it creates what they are looking for at CERN? Let's take a look at that. Now, CERN hits their particles head on, and they're heavy particles. We use the Venturi that I just showed you to crush them into each other's regions. Nothing more than hitting them head on is the same crushing effect. We do it with the Venturi. It's passive, takes no energy, didn't cost $22 billion. So, coming out of our Venturi crusher, which is the same thing they're doing at CERN, we have the Higgs fields they're looking for with the boson particles that they're looking for, which these little tiny slips of particle streams that are spinning particles. They're these particles right here. Zip! And when they hit the atmosphere that is not compressed and making them accelerate, they concuss into the veil of electrons and particles that is in the air. They just slam into these fields. And these fields are the product of that spinning particle, which is charged. It has a negative charge on it. Zzz, it's the center here, spinning like an unbelievable, and all of these particles are chasing around and around as they follow it, just like this would do. Here they are. This is it right here. Zip, coming through. You don't see the particle in the center. You see the effect of its magnetic polarity pushing to the right-hand rule. Get away from me, get away, get away, get away, get away, get away, get away. That's what's going on there. Now, there's a lot more to this. I want somebody to talk to me about this, because this Venturi should be able to do the same thing with heavy particles passively. No additional electricity or anything. You just shoot them through this crushing device. They will force into each other's regions. They're the opposite of these particles, so they must have some kind of region they possess. They will force into each other's regions. They will compress and crush and turn into plasma. They say if they can create plasma, they can create fusion. That's plasma. So I would like to see somebody take an interest in this. It's been years of just neglect on this. So I think I've proven my case damn well. And if this could help in the energy side, I don't want any money. I'm not looking for it. I couldn't care less about money. I just want something to be taken for, if it's true, it's true. If it's not true, good, go about yourself. That is true as far as I'm concerned. Nobody has been able to challenge this. All they can do is ignore it. And this is that same right spinning particle that I've talked about, coming out of here in an accelerated form. You see it spread out, and then it's compressing at the top. So that's the particle spinning to the right, means it's drifting to the left. So now we're going to go look and see what creates a standing wave, resonance frequencies, and I think there is a possibility of pushing electrons away from the core and creating anti-gravity. I believe that's what Hutchison did. I can't be positive. I can't do it. I don't have the equipment to do it. But I think I showed it. It's called attenuation. Let's take a look at it. Is mutation possible using attenuation. So what is attenuation? Attenuation means to stretch the wave, to take one wave and push it against another to draw it apart. So why would that give us any transmutation? Well, my contention is that the rule of 8 says that there's 8 electrons in the valence shells. Now, I drew this backwards. The red should be way out at the end because that's the least, out here will be the least held. The closer to the nucleus would be the blue, the green would be in the middle, and the red would. So the red and the green, red and the blue are reversed. The red would be very low frequencies way out here, and the blue is very tight and would be in close because it's held tighter. And to get away, it would have to fire off much harder. That's why hydrogen, I believe, has extremely high Fraunhofer lines, very short, because it's extremely close to the nucleus. And then you go, the rest of them are the 8 running around until they fall apart. And that's the other 8 major Fraunhofer lines. It's called a rule of 8. So I'm sort of putting these things together and they make sense. Now, so if we could create a standing wave, which my contention is, it's not a wave, it's not just something flapping like this in the breeze, it's a spinning particle. Now, which means this one's going this way, this one's going this way. We're hitting them head on. Now, at that point, they just smash up and they literally stop. I mean, boom, you're stopped. Because, whoops, this continues to screw into each other and it's just continuing to stop this wave right here where they meet head on. That's the only thing I can take away from it. Now, if you could somehow introduce another wave to this standing wave, which is now where our zone is of our electron, so we go at that frequency and then we extend that frequency and push it out, or shorten it, or whatever you have to do to move this shell out. And that, at some point, should break this atom into some different atom. It will take away and move the electrons, which are firmly held within the very core. Because you can't, the valence are made to be able to move in and out electrons, no big deal. But from down in here, I believe the S1 orbital is the key. And I believe it's the S1 orbital that actually controls the hydrogen and helium are anti-gravity. Not that they're just light. They're anti-gravity. They're more positive than they are negative, so they're pushed away from the Earth. That'll give you something to think about. All right, now don't forget, I'm claiming that we might be able to create plasma with the Venturi as a static device. No additional input whatsoever. Just bolt it down, shoot the stuff through it, and it will come out plasma. It's what I've seen in our experiments. So, what is plasma? State of matter along with solids, liquid gas. It consists of a partially ionized gas containing ions, electrons, and neutral atoms. That is being crushed through the Venturi. We'll do this. Now, they're doing it with heat and forcing it and this and that. And then they are going to be able to create fusion. But the plasma is the key. So, I think I've shown that we'll be able to create plasma with a Venturi. And that is as simple as it gets. If that's true, it's a whole new world.